I will hand over to Jennifer. And again,
Sure.
Thanks for joining, Jennifer.
Yeah, no problem. So I think I will unmute and then I guess you mute or we have volume twice. I don't know if that'll work because I think, are you using your computer speakers or that? Oh, okay. So maybe it's fine just to speak like this. Can you guys hear me all right?
Okay, we take it down here.
Yeah, I can also move.
No, we can take just this one.
Yeah, just let me know. Yeah, sure.
If anyone online,
just let me know if I'm not clear.
Confirm they hear Jennifer.
Well, that should be really close now. Now you really hear me. Maybe more than they want, but okay, great. So yeah, thank you very much. Happy to be here both in presence and also on Teams. So I'm Jennifer Horkoff. So I'm going to present some of the progress we've made over the last sprint in Software Center number 27. So this is a project with myself, Eric Naus, Jan-Philippe Steekhofer, Hans-Martin Heijn, and Jorg Holtman. And so today you have me here. I realized actually that we didn't put the name of the project on the first slide, and we actually changed the name. So then I was trying to figure out what is the new name. So we used to be Requirements Engineering for Large-Scale Agile, and I think a couple of sprints ago we changed it to be something like Knowledge Flows for Large-Scale Agile System Engineering, something around, give or take a few words, but you get the idea. And so the idea there, I mean, we're kind of requirements engineering, most of us, but we wanted to better reflect a little bit about what we're doing in the project. So it's really more about knowledge management and requirements knowledge management and things like that. So I'll try and keep this to 30 minutes or less to give us some good time for discussion. And what I'm going to do here is basically just give, so I was thinking of like kind of a mosaic of some of the work that we've done in this project over the last sprint. I also really like Helena's description of goodies, so I'm giving you goodies. And in fact, mine's such a mosaic that I've copied and pasted it from various thesis slides. So you'll see every once in a while I change the template just to really keep you on your toes. So the long-term goals of this project, so accelerate large-scale Agile system development by improving engineering knowledge flows. So I think that's where we get our name from, engineering knowledge flows. And so for this goal, we have 2 to 3 goals for this, this sprint, and I think the last sprint as well. So these were our sprint goals going into sprint 22. And we've actually reformulated this a little bit now in our sprint 23 proposal. So at the end, I'll stop by showing you kind of how we reformulated this. But what we were doing this sprint was focusing on coordination through requirements. So improving coordination between methodological agile islands based on requirements-related boundary objects. And this gets into some work that we've been doing over several sprints. So I think like some of Helena's projects, we're also a bit of a, maybe not as old, but an old project. It's probably been at least 10 sprints, maybe more like 12 sprints for us. So we're really kind of building gradually kind of a toolkit of knowledge. So for us in the past, and you'll see some examples, we've worked on something called methodological islands with the idea that there's different pockets of people working to different levels and degrees of agility, and boundary objects, so ways that these different pockets of working kind of communicate with each other, which is usually related to requirements, but doesn't have to be. So how do you kind of use requirements as a method of coordination? We also have a part of the project focusing on traceability, and that's mainly led by Jan-Philippe, who's a traceability expert. So specifically, traceability in large-scale Agile system development. We work on something called collaborative traceability, and we've published a number of collaborative traceability practices or principles, and also focusing a lot on building TIMs or traceability information models. And the third goal for the sprint was contextual requirements practices. And this one's a little bit more new. And so this is something that Eric and one of his PhD students are mainly focusing on, looking at requirement strategies. So how do you, how do you diversify your RE practices, take into account different needs in specific domains through the development cycle? So we'll talk a little bit about this goal as well. So here they have a practical tool and some more sort of philosophical strategies. So our project partners, so we have sort of active partners right now, Ericsson, Grundfos, Saab, Volvo Trucks, Volvo Cars, and Zenzact. And we hear kind of more or less from these partners during the sprint, depending on kind of their availability level. We also have following along Axis, ISAB, Siemens, and Tetra Pak, who in the past have been more active, but depending on what they're up to, they kind of come in and out and follow along. And we have, a lot of a variety of researchers. So, we have kind of the seniors who stick around, and then we have some postdocs, and then some PhD students who come and go depending on what they're up to. So we also had some accepted papers. I won't go through this, but of course, these are all available related to the project. And what I'm presenting here is a mix of work in progress that we haven't actually published yet, a number of different actually theses. So I think this sprint we had 1 master's and 2 bachelor theses, and some results from papers that have been submitted. Some are accepted, some are still in under review, etc. But for most of these things, we have longer write-ups. So if there's a particular subject that you're really interested in, please let us know, and we have more material on pretty much everything. So I think we more or less covered this. So looking at sprint goals. So we've looked at sort of the combination of BOMI and collaborative traceability. I'll talk a little bit more about that one, but not too much. Guidelines for traceability information models. We'll talk more about that, and challenges and practices in relation to requirement engineering and case context. That's a bit vague, so let's make this a bit more concrete. So what we did is we had a couple of different cross-company workshops. So we had one in March. We were focusing on looking at knowledge flows and large-scale agile system development, and looking at how to combine some of our past project findings, like this BOMI, which I'll show a little bit, and these collaborative traceability principles. And then we had a second cross-company workshop in April, focusing on managing test code and requirements and version control systems. And so this is focusing more on a tool called T-Rex, which is something that Eric, along with Ericsson, have developed, allowing you to use requirements and requirements models in a version control system. So it's like a Git for requirements, or checking in your requirements alongside your code in version control management. And then we had an end of sprint workshop where we, of course, reported our results. But we also had some individual workshops. We had a workshop with Volvo Trucks, where we discussed more of this BOMI stuff that I'll show you. We had a workshop in person, and a number of meetings with Grundfos focusing on traceability and designing a traceability information model. Master's thesis work with Ericsson, a bachelor thesis work with Grundfos, and a thesis work across all the companies. So I'll give you some highlights for that. So here's our deliverables, and I crossed out the second one, not because we didn't do it, but because I'm not going to talk about it, or we'll be here forever. And that one's a little bit more abstract anyways, so that you need to kind of have a bit more background knowledge there. But I'll talk about the first, third, and fourth bullet here. So facilitating teams to manage test code and requirements, BOMI usability improvements, which is one of our bachelor theses, and collaborative traceability practices and guidelines, TIM design for large-scale agile. Okay, so this first topic, so facilitating teams to manage test code and requirements. So what I'm going to show here is sort of, I think, 3 pieces of ongoing work. So one of which is work that's, I think, been submitted. Another piece of work was published, and a third piece of work is a master thesis. So all kind of falling within this umbrella. So a little bit of background here. So this is sort of background on requirement strategy. And this is not our work, but some work from some of our colleagues, well-known colleagues in the requirements engineering field. And so when you talk about documentation and shared understanding and requirements, you could kind of map it out on a map like this. So you have implicit knowledge and you have explicit knowledge, and you have correct or true shared understanding, and then you have incorrect knowledge, so false shared understanding. And then within that, you even have the information that matters and the information that doesn't matter. So here the information that matters is in this kind of green blue bubble, and the stuff that doesn't matter is outside. So for example, you can have kind of this top right chunk where you have explicitly specified and truly understood and relevant information. Great, that's what you want. But then you can have the bottom left bubble where you have both implicit and false information, which is really quite bad. And various degrees of around this sort of map. So I think this is inspiration for my colleague Eric and his PhD student Amna to focus on this topic of requirement strategy. So you can see I'm skipping some slides here. So they are working on a way. So the idea here is it's not just a methodology that says, okay, start here, do this. This is how you work through your requirements. It's an encompassing strategy that encompasses requirements methodology, but also the organization around the requirements and also the structure of the requirements. So for a particular organization or for a subpart of an organization, you would define the structure of the requirements or the common language. So a requirements traceability information model, which is another topic we've been working on. So what does a requirement relate to?
what is the information model for requirements? Define levels and types. So this is a topic that comes up a lot in this project. The various companies usually have requirements hierarchies, but no one has exactly the same requirements hierarchy. So, it's fine to have variation there, but to have a kind of a shared understanding of what are the levels and types of requirements that you have. Define templates and quality criteria. So how do we capture the requirements? What is a good or bad requirement in this context? And then define organization, roles, responsibilities, ownership. So who changes the requirements, who creates them, who reads them, who's responsible for them, etc. And then map the structure and organization to some sort of agile workflow. So this is almost always in an agile context. So, whose responsibility for sprint, definition of ready done, how does this fit into safe practices or the art or the release train, things like that. And so this collection of definitions, concepts, processes is what they're calling a requirement strategy. And I think this is really interesting work, but it's also relatively new. So I think they just submitted it recently. So if you're interested, I'm sure they could share the draft and kind of pay attention, hang on for more words about this, because this is an active topic, I think, in Anna's PhD thesis. So related to this project, there's also been a submission about model-driven requirements engineering with T-Rex. And so model-driven requirements engineering has been around for a while, but this T-Rex, again, like I said, is a way to manage requirements in version control. So to manage requirements as you would code in Git, something like Git anyways. And so what they did is they also tried to incorporate kind of text-based models in this T-Rex, so you can check in and have versions of requirements models. So what my colleague Eric and our former colleague Grisha Leibel, who's now in ISIN, did is they did a survey and follow-up in-depth interviews to understand how model-driven requirements engineering practices are actually working right now in industry and how it aligns with agile practices and what sort of recommendations and ways of working can they make. So again, in the mosaic or the goodies kind of theme, here's a few highlights. So what they did is they did a survey and they had a number of different propositions about models, and then they said, whether or not this proposition can be supported or not from the survey. So I won't read it through it all, but just for example, like models are created by a few experts and mainly read by them. So this is supported. Access to models and especially editing is rare amongst testers and development. So this is partially supported. So, that's true in some cases, but not necessarily universally true. Model creators are not modeling experts, therefore use of modeling languages is ad hoc and varies across the organization. So no, this is not supported. So in fact, model creators are often modeling experts and, etc. I won't go through it all, but these are some of the sorts of findings that they found in this work. Similarly, so here they're kind of listing a number of different features, and then they asked the survey respondents whether they support these features or not. So is it important to have navigation between diagrams? Yes, it's important. Access to requirements models should be integrated with T-Rex, a little bit less important. Requirements models should be used for automated tasks, a little bit less important, but also important, and etc., going down to layout and other topics. And I thought that was interesting. They also asked, which diagram types do you use, creation or usage, for expressing requirements? So you can see here activity is the most popular one, then sequence diagrams, and then use case diagrams, state machines, other, and very rarely or more rarely class and component diagrams. So it's also interesting to understand what sorts of diagrams they're using in order to represent requirements. And finally, actually, I think this is my second last point here. So they also looked at different use cases for requirements modeling. So what they were envisioning is that these types of models would complement existing textual requirements with an overview depicting relationships. So it's not that you use text or models, it's that you use text and models. And provide value information to inform their activities. So many read, few write, but then there's maybe a potential imbalance there. So some more is possible scenarios. So you can, entirely abandon requirements modeling in favor of using other artifacts, or you can use requirements model as a source of information for system managers only, or for developers, or you keep them kind of as a first-class object and maintain the model by the entire development organization. So these are some of the possibilities. And in the end, to summarize, the recommendation was to use models, but to use small models. Maintained by the entire development organization. So this is kind of their takeaway message from all of the data they gathered. So these small models can be easier to maintain, update, and review. They could be robust against different styles. So the style doesn't matter as much if the model is smaller. They can have a low abstraction level. so they can be useful in concrete development tasks. So not necessarily a very high level model, but maybe like a model for corresponding to a couple of different requirements or a specific feature. And then layouting is a bit less of an issue. And so they found that text-based modeling in Git, which is what they've been doing with this T-Rex, makes sense. Because it's a lot easier to keep requirements up to date and keep these models up to date. So you don't necessarily have to be updating the lines and the boxes and stuff when the system updates. So it's more about just updating the descriptions and text and then checking that into a repository as you would do with code and with textual requirements. So like I said, that's a very high level overview of their findings in this paper. So this one, I think it's either been submitted or accepted, actually, I'm not sure, but there's a full text here. So if this is a topic that interests you, just let us know and we're happy to share more information with this one. So the third subtopic in this first subtopic, so this is the master's thesis. So Eric supervised a master's thesis on automated feedback on requirements in continuous software engineering by Brigitte and Heldrum. And so they've already defended, so this thesis is available. I don't think they have a subsequent publication, but there's a full master's thesis if you're interested. So again, requirements reviews are hard to integrate in Agile workflows, so there's a bit of a challenge in integrating this kind of more traditional practice. Existing automated quality checking is not really suitable for Agile workflows. So they were looking at things like, what are the main problems of requirements verification and validation in Agile systems that can be addressed using automated feedback? So is there a way to automate feedback in this context? What are some potential solutions? And then once they've come up with these potential solutions, how do these potential solutions help address these problems? And so this is a kind of a typical design science setup where they did interviews, workshops, prototyping. So during one of our cross-company workshops, they had a Miro exercise where people were kind of prioritizing their findings and etc. So I only show one slide of their findings, and there's a full thesis available if you're curious about this one. So they, for example, found a number of problems solvable with automated requirements feedback. So they classified these into change history problems, interdependency problems, language problems, and technical problems. So just to pick out a few as examples. So in change history problems, lack of complete change descriptions in Git commit messages, and so that could be solvable automatically. For example, keeping requirements up to date is complex. Language problems, writing guidelines for requirements are lacking, increasing likelihood of mistakes. So that's something that could be solvable automatically, or at least maybe partially automatic, maybe not fully automatically. Yeah, testing non-functional requirements is complicated, interdependency checking is lacking, etc. So this would be a description of some of their challenges, and then they had some suggested solutions and evaluated those solutions. So yeah, sorry for not going into more detail, but are happy to provide the full master's thesis. Okay, so that was the first topic, and now we get into the second topic. So we also did a little bit of work more on this BOMI topic, which is something we've been working on for many sprints. So here we're specifically improving the usability, but I'll talk to you a little bit about what this actually is, so it's not completely confusing. But this was a bachelor thesis supervised by myself and Jorg, and the student was Victoria Vu. So this is the meta model of BOMI, and so here we have boundary objects, that's the BO part of BOMI, and this is just something that the various methodological islands exchange in order for coordination. So it can be requirements, it can be features, it can be test cases, it can be, so anything that you exchange between teams or between methodological islands or between organizations in order to coordinate as part of large-scale development, this could be a boundary object. And then you have the roles that use this boundary object. You have different methodological islands, which are parts of roles that use these boundary objects. And we say methodological islands, this could be different teams, or it could be different groups of teams that use different flavors of Agile. They could be separated by geography, so maybe some people are in Sweden, some people are in China. Could be separated by organizations, so some of them are systems, some of them are hardware. So there's different sort of drivers that drive people to kind of work in sort of pockets or islands, and these islands must coordinate, and they coordinate through boundary objects. And the last thing I'll say about this is that these boundary objects are governed in a certain way. So some of these rules are part of a governance team. So in a concrete example, if you have boundary objects as a requirements document, someone's responsible for creating them, someone reads them, these different roles are probably part of different parts of the organization, and then subset of this role is responsible for governing the requirements to say, you know, who approves changes or major changes, for example. So we've been working for this for several sprints, and what Victoria was doing is basically just trying to find views over these models in order to make them a little bit more easy to use. So that was her bachelor thesis. So the problem is this here, I'm not explaining this, but this is what an instantiation of this actually looks like in practice. So this is a model that we drew in a past sprint with one of our companies. Here the boundary objects, which you can't see, is test cases. So you have test cases, all the various roles that use these test cases and all the islands they belong to, how the test cases are governed, etc. So this is fine, but this is a complicated view. And so what Victoria was trying to do is to find subviews over this to make it a little bit more easily digestible. And so she was trying to understand, you know, who are the main BOMI stakeholders, who uses this, what are their main concerns, what aspects do they need, how can the elements and relationships be used in order to meet those concerns, and then are these views that she created helpful? And so she also did design science with a number of different surveys and interactions with our company participants as part of our workshops, and then she finished her evaluation just in May. So she found that the main stakeholders of BOMI were process methods tools experts, managers, system engineers, development teams, requirements engineers, and architects. And she got that from survey information with our company partners. And these various stakeholders have different concerns, so understanding and managing methodological islands, understanding various coordination aspects, providing an overview or other things. And she used this collection of concerns to come up with a number of different views over these BOMI models. And so she came up with 4, but I'm only going to show you one just to give you an example of what she did. So we'll show the boundary object view type. And this is what it looks like over the meta model. But I think more interesting is for each of these view types, she said, you know, who is the stakeholder? So in this particular view type, the stakeholder was all those interested in this particular boundary object, managers, developments, or development teams. And the concern with this particular view is to identify those involved in a specific boundary object and their responsibilities, and understand how a change in the boundary object might impact others. So if you imagine a boundary object like test cases, for example, you know, if you make a change to the test cases, who's affected by this? Who do you need to inform? You know, how, if I want to do something different with it, who do I need to talk to? Who's dependent on this boundary object? So this is the sort of use case for this particular view. And it's basically, if you know anything about models, I mean, it's a view. So you have a big model, and then you make it smaller by hiding some of the model elements. That's basically the idea. So you have this big model that shows all sorts of things, and then you have a small view that only focuses on the boundary objects and the roles that use them. And so she did evaluation for these 4 different views and in a number of, I think in the final sprint workshop, and she found generally, you know, they thought they were useful. One of the interesting findings is that there's a bit of confusion between kind of making these models versus reading these models. So these views are helpful for reading these models, but they're not necessarily as helpful for making the models. So maybe we need a little bit more help in order to guide people in using BOMI in order to understand kind of the landscape of the organization. Yes, exactly. All right, so we skip back to a different template now. So the third point I want to talk about is our work in collaborative traceability practices and guidelines. And then we can start to sum up here. So here we did 3 different things. We had a workshop on collaborative traceability, mainly with Grundfos. We had also a bachelor thesis on traceability dashboards, and we had validation of some traceability scenarios. I actually kind of think it makes sense to start with this third. Yeah, let's start with this one. So we've been working with Grundfos for at least 2 sprints, but maybe we started even before that to help them design a TIM, essentially. And this is a traceability information model. So they did have one, but my colleague Jan-Philippe and his former PhD student Salome had created this methodology called Traceable, which is a way to guide an organization in order to make a traceability information model. So we've been essentially for the last year applying this at Grundfos in order to help them design a traceability information model. So we did workshops last sprint, and then this sprint we also did another in-person workshop talking to various people who would be involved in traceability, so system engineers, test engineers, etc., to understand what sorts of scenarios they would work with in terms of traceability, what sort of artifacts, what are their challenges, etc. And so what we did is we came up with a number of different traceability goals, and we came up with 3 or 4 kind of key traceability processes. And then what we were doing this sprint is kind of validating this work, again, with some of the experts at Grundfos and identifying obstacles. So all of the traceability scenarios we found are relevant. We updated some workflows with some additional information that we found when we visited. And yeah, so there's also some challenges in agreement about, where exactly and how much documentation should we have. And also data consistency is an ongoing challenge. And so we've been using this information to update the TIM with various information and link semantics. And then the handover point is basically, we kind of give Grundfos these goals, the scenarios, the TIM design, and they use that internally in order to apply these processes and see how well they work within the company. So related to that, we also use these strategies, these scenarios that we came up with, so these real traceability scenarios of the organization, in order to kind of validate our previous work on collaborative traceability. So in this project, we've also come up with a number of collaborative traceability practices, and so this also came from working with the companies. So these are things like developing a TIM, having upfront traceability, and basically seeing traceability as a collaborative artifact that kind of is not just a thing stored in the system, but it's something you work with collaboratively as part of a team. So we used the information gathered from Grundfos to kind of validate and test out some of these scenarios or some of these traceability practices in another workshop. So we found some findings. So for example, role-specific traceability documentation is essential to establish necessity for traceability. So for each role using traceability links, it should be clear why this traceability link is needed or how you use this traceability link. Otherwise, no one will ever use it. But in another counterexample, so persistent trace link rationale on a case-by-case basis does not necessarily add value. So you don't necessarily need to know the rationale for every single trace link. This is something that can be recorded in the TIM. So that's just an example of the type of findings that we found related to this collaborative traceability work. And the third thing about traceability is that there was a bachelor thesis also run at Grundfos, supervised by Jan Philippe. And so they were helping them to design, evaluate, and improve a traceability dashboard, so visualizations over their traceability links. And so they did the kind of the standard thing, interviews, observations, etc. And so this dashboard they found is mainly being used to understand if requirements are verified. And there's challenges in terms of data quality and trust, data volume, not necessarily integrated into their current workflow. They have a lot of different tools they use in parallel. And then they had some improvement suggestions, so filtering functionality, additional information such as requirement owner, release, last update, data source, requirements coverage, etc. So this is another thesis. So if you're interested in the topic of traceability dashboards, please let us know and we can give you a 10-page thesis that describes their work specifically in this area. Okay, so I'm almost done actually. So that was maybe a very fast kind of goodies. So I think I advertised at the beginning that, we had these 3 different goals and we kind of revised them a little bit based on what we've done this sprint and also based on discussions with project partners, especially our end of sprint workshop. So I think that this project mission is exactly the same, but now you see we have 2 goals instead of 3. So one thing we're going to focus on now is design and evolution of information models. And this, we find that talking to a lot of the companies that we're working with, most of them are actually having kind of these global widespread information models internal to their company. And so this is kind of like this TIM that we were talking about, this traceability information model, also kind of like what we would call a RIM or requirements information model, but combined together with more of a system architecture view, and it could be more of a process view, etc. So given that these companies have and are interested in these large-scale information models, how does that align with some of the things we've been working on? So things like BOMI, RIMs, TIMs, etc. So we're interested in providing a conceptual tool set to create, main, and manage the evolution of engineering information models and scaled agile system developments. And so this also fits very well with this work on looking at how people use requirements modeling in practice, this BOMI work, looking at how you can use these sorts of models to manage information flow. So how does BOMI fit into the information models that they have now, etc. So that's something we're going to look at more in Sprint 23. And then getting more into sort of this requirement strategy area, so knowledge and information management strategies. And so here I think we're going to continue on with this work specifically in T-Rex, so looking at how to manage requirements knowledge and how to support tooling in that area. And this idea of a requirement strategy, if you remember, I presented quite a few different slides ago. So for managing knowledge, information, large-scale agile system development. So how do you, if you want to define a requirement strategy, what sort of elements do you need to define and what do you need to take into account about your specific context in order to define a good strategy? And so, yeah, the last slide. So our Sprint 23 goals. So continue to investigate how potential combinations of BOMI and collaborative traceability principles can be used to facilitate engineering knowledge flows in large-scale agile system development, which I think is actually the title of the project, facilitating engineering knowledge flows in large-scale agile system development. And then the other new-ish topic that the company partners are really interested in is relating some of these topics to system engineering and knowledge management principles. So how do things like BOMI or collaborative traceability relate to system engineering principles? Is it covering the same thing? Can we learn things from system engineering principles? Have we come up with things that aren't covered by system engineering principles? So that's one of the topics we're going to get into a little bit more coming up in the autumn. Yeah, and I think that's pretty much covered by that bullet. And then I realized I didn't have an ending slide, so that's my ending slide. So thank you very much for your attention. And here's my email. If you want more information on any of these subtopics, please feel free to contact me. We have all sorts of papers and theses and everything else to share with you. And I think, yeah, that's it. So hopefully we left enough time for discussion. So thank you very much.
So thanks a lot, Jennifer. Maybe, so any questions, Jennifer, and you choose if you want to keep sharing.
I can stop sharing.
If someone has a question, feel free to
that's
unmute and maybe show your face. It's always nice.
Yeah, if you have a question on the slides, I can always go back and find the slides.
Yes, exactly.
Otherwise, we can have a more general discussion as well.
And this is the adapter here, which is really sensitive. Is there a question to Jennifer?
We can see Jennifer on the screen now.
Big screen, yeah, sorry.
See, she's there on.
Yeah, I'm very big on there. So we used to have this camera up here showing all of us, but I think it disappeared.
We have had the connection here during the day a bit unstable with regards to the screen in the room. It is really, I don't know the word, picky or sensitive or not so agreeable, but here we are. Is there any questions to Jennifer? Anyone in the room? Mm-hmm. I think they can still hear us even though they cannot see us.
Yeah.
Or we cannot see them.
They can see me.
They can see you. Good.
Can show everyone else.
Good.
But yeah, sorry, that was kind of a brain dump of information. But like I said, it's like a mosaic or goodies, a highlight of some of the things we've been working on. So if there's any specific topic that resonates, just let us know.
I don't know if this is a question, but maybe you can help me out. You talked a lot about, at least you used the word requirements. We started out by instead focusing on the outcomes. I think it is really interesting when you talk about the traceability and how to really help people in large organizations understand each other as well as the requirement they are working on.
Yeah.
Is there a difference? I mean, would you place your work within more of an outcome-oriented? If you would take that approach instead, what would it look like?
It's a great question. Ironically, my PhD thesis was on goal-oriented requirements engineering, so that's outcomes.
It is a question.
Yeah,
exactly.
You know the answer. So I mean, we worked. there was I didn't invent goal-oriented requirements engineering. It's been around since the 90s, and I worked a lot specifically in modeling. So it's not just getting to the requirements statements like the system shall, or even user stories. As a user, I want this. It's more about, who are ecosystem models, who are the actors, what do they want, what are their kind of what we call hard goals or their kind of quality goals, how do they depend on each other? And this is, I think, is a really useful way to view requirements engineering, and I still very much resonate and make use of the concepts. But what we found is, of course, the models we drew were very large and complicated. So you saw these BOMI models. I think the goal models were even worse. So I very much agree that outcome-oriented requirements engineering or focusing on outcomes is a really good thing to do. But what we found over the years is that, the concept of goal didn't necessarily resonate that well in practice. It was much easier to talk about functions and requirements than it was to talk about goals. But again, the difference between goals and requirements is really quite fuzzy. In some views, they're almost the same. Like, what do you want the system to do? I want the system to do that, then it's a goal. Or what do you want to achieve in the world? Like you mentioned, like crew happiness. So that was some of the types of goals we would work with in my PhD. That was what we call the soft goal. Yeah. And I think it's really nice to have those things explicitly up front as you were doing, in your presentation, but eventually, of course, you have to measure them, which is what you were also working towards. So a long answer, but short answer, I agree with you. And we tried to do that kind of in a different paradigm with goal orientation, but mainly taking a model-based approach. And also, as you can see in the slides from Eric and Grisha, probably the model-based approach that we were taking is not necessarily the type of approach that would fit well in large-scale agile. So it didn't really take off too much in industry, but I think conceptually it's still very useful.
Thanks. Are there other questions?
No, it's maybe not a question really, but in our work with requirements, I think we often don't agree when it comes to, we think we know, so like you talked about, Lena, we think we know what the goal or what we want, but even the requirement can be fuzzy in some ways. So business comes with a requirement, the developers think they know what it is, and they start developing something and they deliver, and the business side says, this is not what we wanted. Yeah. So I think that's sometimes our main challenge. I think just the practicality of actually even getting requirements passed across. And I don't know.
Yeah, I think that's definitely a fairly frequent challenge. And I guess one of the solutions would be to not just pass requirements. So getting into Helena's work, you'd probably pass values and outcomes and things like that. And in my old work, you'd pass the goals behind the requirement, ideally. And then from a traceability perspective, ideally, you'd pass where that requirement came from. So, a better connection to kind of customer value or, so you can understand the intention behind the requirement and not just the requirement itself. Because, of course, requirements are vague and can be misinterpreted. That's one way. Of course, the other way is to, have this requirement more like a boundary object and to have more frequent communication, collaboration. Is this what you mean? Is this really what you mean? And not just a handoff. So a little bit of both, maybe. So I'm not sure what you say, Helena.
Anyone online that would want to jump in? If there's a question, just unmute. If people are happy, maybe it wouldn't hurt with a bit of a leg stretch. I don't know, but it could be nice. Because what happens now is there is a keynote at 3:15.
Okay.
So we had planned for a break anyway. And if there are no other questions, maybe one thing that I should say, we talk now about sprints. We talk about proposals and plans and wishes for going forward. What will happen is that all projects have already submitted the sprint proposals. They were shared with what is called the task force in the software center, which is key people within the companies, more on the technical side, active in projects, those we have been working with for a long time. They meet tomorrow afternoon. They prioritize, so they have some kind of prioritization of projects. And then the steering committee, which is also fully industry-based, only the partner companies, they meet on Monday. So the steering committee meets on Monday, and they are the ones then approving based on the task force recommendation, you could say. So next week, the projects will learn if they are funded for continuation, and we also will learn if there are a new projects, and maybe some projects will be closed. That's the beauty of Software Center. So the next sprint, or every sprint, looks a little different. There is something new, there is something maybe closing, and then there are projects that have been around for a long time, but they of course also change. But it is always the companies who decide, because they are the ones funding these projects. So that will now take place.
Yeah, so I was speaking a lot about Sprint 23 in the last few slides, but that's our optimistic view, assuming that we're approved for Sprint 23, which we never really know. But I mean, we do have some active company partners, so
You have to be optimistic. If
Yeah,
you're not
exactly.
optimistic at the day, then you aren't done.
we have to do sprint planning whether the sprint happens or not. So.
And you have a very good track record, so I could well see that. But then, if nothing else, thank you everyone